Hello students, in this video I am going to explain how to do calculations for LCR series experiment for graduation students. So these are the readings I have taken from the device. For the inductance 5 millihenry, capacitance 0.1 microfarad and resistance 220 ohms. I have taken the readings with the frequency versus current. Frequency is in kilohertz units and current is in microampere units. So frequency for 2 kilohertz frequency, it is current 4 microamperes. So as frequency is increasing, it is observed that current is increasing, reach it to a maximum value. So here I have got the highest value at 7.45 microamperes with the frequency 7 kilohertz, and later again it starts decreasing values. So for this, let's do the calculations. For this, we have to plot the graph, and the graph paper here used is semi-logarithm graph. On x-axis, we'll have logarithmic scale, and on y-axis, we'll have normal scale. So on x-axis, like this, from this part to this part will come under as one cycle. Here you can see, like as it is logarithmic scale, it starts with 1. After this, this line will become 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, and this one is 10. So this 1 to 10 as comes under one cycle, and the next cycle, it will be multiples of the 10. So this will become 20, 30, 40, 50, 60, 70, 80, 90 and 100. As our readings are in this range, so I am stopping here. If our readings has crossed this range, again this cycle will become the multiples of this 100. 200, 300, 400, 500, 600, 700, 800, 900, and it is 1000. Here as frequency is taken on x-axis, our frequency is in kilohertz units. So this will become 1 kilohertz, 2 kilohertz, 3 kilohertz, 4 kilohertz, 5 kilohertz, 6 kilohertz, 7, 8, 9, and this is 10 kilohertz. After this line will become, in between this 10 to 20, again 10 lines are there. So this will become, this is 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. And on y-axis, our scale is as normal, and our current readings is variating between 4 and 7. So I am taking like scale, ordinary scale. So this starts with 1, this is 2, this is 3, 4, 5, 6 and 7. So let's start marking the points. For 2 kilohertz frequency, the current is 4. So this is 2 and the current is 4 means like this is 4. So I have marked a point there. Then for 3K, the current is 5.25. So this is 5 and this is 5.1, 5.2. And 5.25 is in between 5.2 and 5.3. On rounding, it will become 5.3. So I am marking it 5.3. And for 4, it is 6.6. So this is 4, 6.6. So this is 6, 6.1, 2, 3, 4, 5, and this is 6. And for 5, it is 7.2. So like this, we have to mark all the points. 7, 7.45. On rounding it 7.45, it will become 7.5. And 8, it is 7.4 again. 9, 7.2. So this is 7.2. 10, it is 7. So this is our 10 line. So it is 7. And for 11, it is 6.8. The 11 is this line. 6.8. This is 6.5. 6, 7, 8. For 13, 6.2. For 14, it is 6. For 15, 5.8. So for 16, it is 5.4. So if you got the idea how to mark the points, you can skip this part and you can move to the calculation part. For 19, it is 4.8. For 20, it is 4.6. For again 30, for 30, it is 3.5. This is 30 line. It is 3.5. This one. So join the points. If any point is getting deviated, you can skip those points. You will get graph line like this. So as frequency increases, current increases and then decreases. So whatever the maximum current you got, that is your I maximum. Plot a straight line from I maximum to here. So mark this as I maximum. And where that high maximum comes, that frequency also you have to mark, that is your resonant frequency. Draw a line, show your resonance frequency FR. Then you have to find the bandwidth. For this, measure I maximum by root 2. I maximum is equal to, it is 7.5. So I maximum by root 2, that is 7.5 by root 2, that equal to 5.3. As 7.5 is in microamperes, this is also in microamperes. So at this 5.3, we have to draw a line. So this is like 5 and 5.3 this is. So at this 5.3, a line should be marked, and this is the lower cutoff frequency and this is the upper cutoff frequency, where this I maximum by root 2 will meet our graph line. So from lower cutoff frequency, draw a line, that is F1, and from upper cutoff frequency like this, draw a line down, that is F2. So we'll get F1 is equal to, it is 2.8 kilohertz. That is from graph we can see, and F2 is equal to 17 kilohertz. So here you can see it is 17. So bandwidth formula is delta F is equal to F2 minus F1, that equal to 17 minus 2.8, which is equal to 14.2 kilohertz. And then we'll be finding the quality factor. Quality factor formula is resonant frequency FR by bandwidth delta F. The resonant frequency from the graph, we got it as 7, and delta F is 14.2, that equal to 0.49. So this is about quality factor. Now we have to find resonant frequency theoretical value also. The practical value will be getting from the graph, right? So the practical value of resonant frequency, it is 7 kilohertz. So theoretical value means the formula for this resonant frequency is 1 by 2 pi root LC. Already it is mentioned that the L we have taken 5 millihenry, which is equal to 5 into 10 power minus 3 henry, and C is equal to 0.1 microfarad, that equal to 0.1 into 10 power minus 6 farad. Okay, this whatever the L you are taking, that you have to take. Whatever the C you are taking, that you have to take. So substitute in the formula, 1 by 2 into 3.14 root of 5 into 10 power minus 3 into 0.1 into 10 power minus 6, which is equal to 1 by this 2 into 3.14 means 6.28 into root of, this is 5 into 10 power minus 3, 0.1 means 10 power minus 1. So this is 10 power minus 6, altogether 10 power minus 10. Calculating this, 10 power minus 10 coming out of the root, it is 10 power minus 5 in the denominator. And on calculating all this, we'll get 0.0799 into 10 power 5 hertz. This I am separating 0.07119 into, this is 10 power 2 into 10 power 3 hertz. So 10 power 3 hertz means kilohertz, and 10 power 2 will be multiplying to this. This will become 7.119 into into won't come. This 10 power 3 is kilo. So this is kilohertz. This is the theoretical value. So we got theoretical resonant frequency, and we already had practical resonant frequency, bandwidth measured, and quality factor. All these values to be substituted in the result. With this, your calculation part is completed.